Like terms are terms that have the same variable to the same power. Okay, let's have a look. We might have 4x and negative 7x. They are what are called like terms. They both contain only one variable and they've got the same power, the power of 1. It does not matter what the coefficient. This is the coefficient. They can be unequal. The coefficients don't have to be equal, but the variables are the same and the powers of the variables are the same. So if we had 3n and negative 2n squared and 5 square root of n, they are not like terms. Because it doesn't matter what the coefficients are. Okay, they can be different. But here we have an n to the power of 1, n to the power of 2, square root of n, or n to the power of 1/2. So they are not like terms. And the reason we make the difference between what are like terms and what are not like terms is the fact that we can add and subtract like terms only. So let's just looking at addition. So we got 4x plus negative 7x. Now, there is like a multiply here, understood, between the 4 and the x and the 7x, but it's like you've got 4 lots of something and you take 7 lots of something. We just do the addition in this case because we're adding. With subtraction, you do the subtraction of the coefficients and just put the variable at the end. So it's 4 plus negative 7 is negative 3. That many x's remain. So we've got 4 x's, we add negative 7 x's, then we are left with negative 3 x's. So you do the mathematics just on the coefficients, and then you just put the variable afterwards, as long as we've got like terms. So if we've got 2h minus h, now probably this is the only time you'll do this, but let's just put a number. If there is no number in front of the variable, we can just put a 1h. So there's understood to be a 1 there. Now we just use our rule, so this is subtraction. We've got 2h minus 1h. We do the mathematics on the coefficients. 2 minus 1 is 1, and then we just put the h. And we don't tend to write 1h, just as we didn't there, so that's just equal to the variable h. That's just with one variable. If we had 4xy plus 7xy, first of all, to be able to do addition, we look to see that the variables are the same and the powers are the same. So we've got x to the 1, y to the 1, x to the 1, y to the 1. So these two terms are like terms. So we add the coefficients, in this case we're adding. So 7, 4 is 11, and we just put x, y at the end. And if we do that, we can do a subtraction here too. So if we've got negative 10 h squared k minus 7 h squared k. Like terms because the variables have the same power. So we got h squared k. Now let's just put plus 5hk. Alright, let's just make it a little bit different there. So we then go through and say, do we have like terms? Well, the two like terms are these two. hk is different because these are both h squared k's and this is a hk. So our answer will just have a 5hk at the end. We can't combine it with this. And then if you take 10 and take another 7, you're actually taking 17 h squared k. And that's as far as you can go with that one. So like terms can be added and subtracted. Only like terms. We just saw in this one, if you've got unlike terms, you've just got to leave them out. If we want to look at multiplication, so any terms can be multiplied and divided. Any terms. So if we've got 4a times 3b, doesn't really matter. We don't have like terms, but it doesn't matter. What we can do is we can do multiplication in any order. So that's 4 times a times 3 times b. Understood between that 4 and a is a times, understood between the 3 and the b is a times. We simply just multiply the numbers together. 4 times 3 is 12. And then we multiply the variables together and we get AB. Now understood between all those is a multiply. So it's 12AB. That's multiplication. Division, 13HK squared divided by 39 HK. Now it's probably easiest with these to write them as a fraction, which with the line in the fraction is called a vinculum. So we'll put this as the numerator, 13HK squared over 39HK. Now, if you remember your laws of indices, we can use that to simplify this. Now, before we look at the h's and the k's, let's look at the numbers. 13, is there any number that goes into 13 and 39 evenly? Well, 13 goes into 13 once and 13 into 39 3 times. Now look at the h's. H goes into h once, h into h once. And we want to end up with positive powers. So this is k to the 1. So when we divide, we've got more positive powers of k on the top. So we will divide, and divide you subtract. So 2 minus 1 is 1. So the k will end up being on the top, and it'll be k to the power of 1, which is just k. So it's 1 times k to the power of 1, that's k. And then 3 times 1 on the bottom. Multiply, and that's just equal to 3. Okay, another way to write k on 3 is 1/3 of k. Either one of those is going to be fine. So let's going back with like terms. Like terms can be added and subtracted. If they're not like terms, you cannot add and subtract. You just got to keep them separate. When we think about multiplication and division of terms, they don't have to be like. Here we've got two lots of unlike terms, one multiplied together. You just multiply the coefficients and multiply the variables. And here we do a division, which we set up as like a fraction. We cancel down and we simplify that way.